Today we're going to begin Unit 11 on sequences and series. And in Lesson 1, we're talking about arithmetic and geometric sequences and the difference between the two and how to find the next few terms in an arithmetic or geometric sequence. Basically, a sequence is a list of numbers that are arranged in a specific order. You might add a certain number to get the next number. You may multiply by a certain number to get the next number. And in today's lesson, most of the time we're going to figure out what that number is that you're adding or multiplying to get the next term. An arithmetic sequence is a sequence where you have to add to get to the next number. So it's possible to have positive or negative numbers as your number that you're adding to get to the next term. In a geometric sequence, we're going to be multiplying to get to the next number. So if you're adding to get to the next term, it's arithmetic. If you're multiplying to get to the next term, it's geometric. That's the main thing for today's lesson. The third type of sequence that we're going to talk about is recursive, and we won't do that until near the end of the chapter. And in a recursive formula, neither of these methods work. You're not adding a consistent number to get to the next term, and you're not multiplying by a consistent number to get to the next term. You're using different terms within the sequence to get the next term. Usually with those, we have some formulas that we just have to plug into to find the next terms. Here are some examples of the type of problems you're going to have to do in this section. The directions are going to say either find the common difference or find the common ratio. And you need to understand what a common difference and a common ratio are. If we have an arithmetic sequence, the number that you are adding to the term to get the next term is your common difference. So the common difference is the number added. So if it tells you to find the common difference, automatically you know it's going to be arithmetic. And you know you're going to add to get to the next term. So if you look at this, negative 10 goes to negative 5, to 0, to 5. What are we adding to get to the next term? Well, we are adding a 5. So our common difference, or D, would be 5. For this one, 7, then 2, then negative 3. Our common difference, well, in this case, these are going down by 5 each time. So if they're going down by 5, we're adding a negative. In this case, we're adding a negative 5. Here we've got 2, 2.5, 3, 3.5. Our common difference is 0.5, or you could say 1/2. Either way would be fine. Another thing they might ask you to do is they may ask you to find the common difference and then find the next 3 terms. Well, for this one, the next 3 terms would be, let's see, the difference was 5, so we're going to have a 10, 15, and a 20. For this one, the next 3 terms would be negative 8, negative 13, negative 18. For this one, the next 3 terms would be 4, 4.5, and 5. So we could use what we find as the common difference to extend the sequence out further, or we could just find the common difference. They may ask us to do one or the other. In the next one, this says find the common ratio. Well, the common ratio, anytime you hear those terms, common ratio, automatically you know it's a geometric sequence. In other words, we're multiplying to get the next term. So with this, you have to decide, what am I multiplying by to get to the next term? Now, the easiest way to do that is take one term and divide that term by the term in front of it. If you know it's a common ratio, if you know it's a geometric sequence and you know that you've multiplied to get the next term, and they'll give that away by asking you certain things, all you have to do is take one term and divide by the term in front of it. And you could take either of the terms and divide by the term in front of it. 6 divided by 2 is 3. 18 divided by 6 is 3. Here, the common ratio, or R, is 3. For this one, 5 divided by 10 is 1/2. So the common ratio is 1/2. For this one, 27 divided by 81 is 1/3. Now, I do want to specify, make sure when you're finding these, don't put 0.3 repeating. That's not going to give you exact answers. If it's going to be a fraction, you have to use that exact fraction. Do not change it to a decimal and use an estimated rounded version of the decimal. That won't work. So 27 over 81. Then if you simplify that fraction, you can get your common ratio. So 27 over 81 simplifies to 1/3. And you can do that in Desmos or a calculator. They will simplify those fractions for you. So it's very simple. For this one, -3 over 1 is -3. 9 over -3 is -3. So here, my common ratio is -3. Now, notice what happens when your common ratio is negative. Every other term will be an opposite sign. So every other term will be positive. Every other term will be negative. That's important when you're trying to identify different types of formulas. If you're alternating between positive and negative terms, it has to be some sort of a geometric sequence. You also may be given some algebraic expressions within a sequence and asked to find what the common ratio or difference are. In this case, it says find the common difference or ratio, and then they give you an expression here with sequences. This one says -3x plus 5. The next term is 0x plus 5, and the next term is 3x plus 5. So you need to look at the patterns here. I noticed that all of these have a plus 5, so the constant in each of those terms is not changing. The only thing that's changing is the x part. And how do I go from -3x to 0x to 3x? Looks to me like I'm adding a 3x each time. So if I'm adding a 3x each time, I believe my answer here would be D. Okay, and you can just test that theory. A -3x plus 5 plus -3 would be a -3x plus 2. That's not what the next term is. So you can eliminate things by plugging in. -3x minus 3x is -6x plus 5. That's not going to match. If you plug 3 or add 3, you'd have a -3x plus 8. That doesn't match. So we know that it's got to be D. If I add 3x, -3x plus 3x is 0x, and the plus 5 comes over. 0x plus 3x is 3x plus 5 comes over. So you can just eliminate ones that you know won't work by trying them, and then figure out what the right answer is. For this one, and remember, they're not telling us whether it's a common difference or common ratio, so we have to consider both ways. Now, if I had said, okay, let's multiply to see if that gives us the next term, -3 times -3x plus 5 would be a 9x minus 15, which isn't even close. So we know we can eliminate multiplication most likely, and the more of these you do, the easier they're going to get. They wouldn't cause a whole lot of trouble, I don't think, with your knowledge of algebra. For this one, we've got 5 and 5 square root of 2. Well, we can't say that we're adding square root of 2 there. That doesn't make sense. If we were adding the square root of 2 to 5, that would be 5 plus square root of 2, because they're not like terms. So we have to have multiplied here to get to the next term. And if you just think about what you've got here, remember, if we know it's a ratio or a common ratio, we know that it's a geometric sequence. And so we learned in the last segment that if we take one term and divide by the term in front of it, so 5 square root of 2 over 5, we will get what our common ratio is. So in this case, it is the square root of 2. So when I give you these type, they are going to be multiple choice. They're not too bad. You just have to consider, have I added or have I multiplied to get to the next thing? And they're pretty simple.